this is that first one, okay? This is exactly how it's going to be on your test. It's going to give you a function that's not in standard form. It's going to tell you to put it into standard form using complete the square, and then you're going to find all this information based on it, okay? This is messy for overall. I think 1, maybe 2 got it 100% right. Some of you just forgot like a bracket, which wasn't a big deal, or some of you didn't finish when I checked it, but this is was a mess, so be really, really careful. So the first thing that we do is, and this is in the middle here, you're going to group together, actually here, wait. Let me do it here. Oh, because this has the sticker on top of it. Okay, we're going to, so up in the top in the blue, you're going to group together the 3x squared and the negative 3x squared and the negative 11x. You're going to take out the negative 3, so it gets pulled to the front. When you take it off of the x squared, it also comes off the x. So this becomes a positive 11/3. Then we take the 11/3, we divide it by 2, which is at the top. No, on the left here. You divide it by 2, which is multiplying by half. You get 11/6 squared. You get 121/36. You add that inside the parentheses here. And normally we subtract it from outside the parentheses. But because you took something out, and you will have to take something out in your test, you're going to have to multiply by what's there before we know what to combine that last term with. So negative 3 times negative 121/36 becomes positive 121/12. We add that to 4, giving a like denominator, and that's that 48/12. Combine, and you get 169/12. That becomes your k. Then to factor this trinomial, we square root the first term. We square root the last term, which is the same thing as before we squared the b over 2. And then you take the sign from the middle, which in this case was a plus. Put in the parentheses and squared, and that's your standard form. So that's going to be part of the responses you're going to put on your test. It's going to say, give me that in standard form, you're going to answer it. Then you get all these questions based on that. So if I take the vertex out, I change the sign, it's a negative 11/6 and a positive 161/12. I would immediately pause and check with the negative b over 2a. So negative b over 2a from the beginning would be negative 11 over 2 times negative 3, which is 11 over negative 6. Make sure these match. At least you know you got that part right, and then you hope like hell you got the rest of it right. But at least you get that part, which leads into your axis of symmetry, right? And then obviously part of your graph. Once you get your vertex, your axis of symmetry is x equals h, so x equals negative 11/6. Your domain, you already know the answer to this question no matter what the actual function is. As long as it's quadratic, it's negative infinity to positive infinity. This parabola opens downward because it's got a negative x squared. So our range goes negative infinity up to the k, which is 169/12. And that gets a bracket. So a lot of you got almost all of it right except for that bracket. Don't lose points on stuff like that. That's silly. That point is part of my graph. There's not an open dot at the top of my graph. So I want to make sure I include it, which is why it gets the bracket. When you go to solve for your intercepts, you can do the even root property over here. I could subtract 169/12, divide by negative 3, square root both sides, and then add. As long as you're comfortable with factoring, it's going to be much easier to come back up to the beginning and factor it. It will be a factorable polynomial. So that's down here in the bottom. I multiplied the first and the last. Negative 3 times 12 is negative 12. Found the factors of negative 12 that sum to a negative 11, which are negative 12 and positive 1, and then factored by grouping. And I got x plus 9 and negative 3x plus 1, x plus 4. Subtract the 4, there's my 1 x-intercept. Subtract the 1, divide by negative 3, and then I get a positive 1/3, and that's the other x-intercept, which is here. The y-intercept, if I plug 0 in, remember I just need the c from the quadratic form, not from my standard form. That would be 0, 4. That's my y-intercept. And then my max is 169/12. You're going to tell me, is it a max or a min? And then you're going to give me the k value there. Then you go to your graph. 169/12 was like, what, 14.5. It's off my graph, so I just went up above my graph. I plotted the point. I labeled it as negative 11/6 and 169/12, and then I drew my graph. Make sure you know what you're doing with these. Obviously, this is a big chunk. All right, second one got a little bit better. Okay, a lot of you made the same mistake, which I tried to write on there. It falls left, rises right. When you factor it, you get to here, okay? And I get x squared minus 8, which can't be factored further, and then x minus 2. The x minus 2 gives you the root that is 2. And then I have to add the 8, square root, putting a plus and minus in front of it. Now, when I go graph it, so when I graph it, I'm going to keep it as root 8 so that it's like a 2.8 because that's easier to approximate. But when you write your zeros on the line, if they can be simplified square roots, they have to be. So you have to rewrite that as 2 root 2. Now it's plus and minus, which means each of them is a root, but the multiplicity is only 1. And then the y-intercept, you plug 0 in for x and you get 0, 16. So 0, 16 is your y-intercept. Then plot those points. So again, we approximate root 8 to be like 2.8, 2.5, anything like that. Negative 2.5, 2.8 is here. Positive 2.8 is here. And then positive 2, this should have actually been a little bit further over. Your graph is going to go up. And you could have just gone up to the y-intercept at 0, 16 because that point's there. You didn't need another one. Down and back up through that. So let me go through this one. I think I have the other one here. This was even better. Okay, overall pretty good. A lot of you forgot the f of x. Don't forget that that's equal to f of x. You're making it a function. But you should have gotten x to the third minus 3x squared minus 26x minus 70. You want to change the signs here. So this minus is like when I do x minus, it goes to both, which made it x plus 4 minus root 2 and x plus 4 plus root 2. The signs on the root should be opposite because that's how they're going to cancel out.
So do you just change the signs?
Mm-hmm.
Okay.
Yep. And then you want multiply all this out first. Make sure your roots cancel and then multiply by that x minus 5. Questions on any of those? So again, not the only thing that's on your task, but those are. Okay. Go through the review because that's where everything is. Okay. I'm actually going to jump to the calculator question and then I'll come back to it because I just want to make sure that I think that's the thing we've had the least amount of practice with. So that last question on the bottom, hardest part. Okay, so the other thing I want to make sure, 5 is that top part, right? This is your combining of the functions. Number 1 was your composite f of g of x. G of x gets plugged into the f of x. And then we find the domain. Remember, when you're doing composite, you have to find the domain of the one on the right. So if g of x had a restriction, which it does, whatever's under here cannot be equal to 0. Or it has to be greater than or equal to 0. Then you combine them and then look at your updated function and see if there's a new restriction. It's the same restriction that was already there. So I just keep that x is greater than or equal to 0. And you're going to write it in interval notation as 0 bracket to positive infinity.
For the g plus f of x and it's find the domain, do you have to look back
at both of them? Because this is different, right? This is, I can take g of x and add it to f of x. So everything except for the f of g and the g of f, you have to go back to both originals and see if there's a restriction, and if there is, carry it down. Then look at your combined, and is there a new one?
That's for domain though, right?
Yep. Yeah, so I had to look at g of x, I had to look at f of x, see if there was a restriction. There wasn't the g, right? Then I have to combine them and see if there's a new restriction. So it's the same one. So
if 4 said find the domain.
Well, it would be an x though.
Okay.
Yeah, okay. But I would do the same thing. Same here. Well, no, this is the composite. So this would have been, I only have to check the f. And then the composite.
But if 2 said 16, like instead of x.
I won't ask for the domain then.
You won't.
I'm only going to ask for the domain if it's an x.
Okay.
Yep. But adding, subtracting, multiplying, dividing, you have to check the originals and you have to check the end. Only composite do you check the one on the right and the end.
For domain.
Yep.
Okay.
Yep. Inverse, remember you're checking, is it, and does it have an inverse? Is it 1 to 1? Be careful with that because if it's supposed to have an inverse and you put none, there go all the points. There's no such thing as partial credit there. And other way around. If there isn't supposed to be one and you put that there is, there's all the credit. So be careful on those questions. 2-1, the first part is basically what we worked through on the class kick, putting it into standard form, finding your vertex, your intercepts, your domain, your range, axis, symmetry, max and min, and then graphing it. And then the reverse, right? So we've got the vertex and the coordinate point. We plug it in. We find the A. And then at the end, you give me back an equation where the A is there and the H and the K. Those were both from 2-1. On 10. Okay, so did you get this part?
Yeah.
Okay, so normally I'd add 25 over 4. I have to subtract 25 over 4. But I took out a -1, so I have to multiply that times it, and that makes it a positive 25 over 4. So I get 6 plus 25 over 4, and 6 over 1 becomes 24 over 4 plus 25 over 4, which is 49 over 4. And then that's your K.
Isn't it originally positive?
God bless you. No, whatever you add in here, you have to subtract out here unless you multiply it to change it the sign. But that's how we balance it. We add it inside the parentheses, we subtract it from outside.
What do you mean multiply to change the sign?
Multiply whatever is here.
Oh,
Yeah.
Can you just lift it up?
Oh, you're totally right.
It should be 3. I got
Is where you will actually start. Okay, tomorrow. You'll start with the calculator part. It is brief. Yeah.
When you're plotting the additional points between the zeros, does it matter, like, if you plot the minimum or not? I mean, the minimum or maximum between them? Or do you have to find the minimum?
You want to find the middle-ish, but it doesn't matter
Yeah,
where.
because, like, if I choose a number, but, like, when I do the curve, like, it's
It
not...
may not catch the max or the min.
Yeah,
It's fine.
is that fine?
Yeah.
Okay.
Okay, so this question said the path of a diver is approximated by the following, where y is the height in feet and x is the horizontal distance in feet from the end of the diving board. So you're going to get some sort of quadratic. It's going to be yucky. You got to make sure you know how to be able to plug that into your handheld graphing utility. And then you're going to get only one question, but it could be any one of these types of questions, okay? And you've got to know from the wording on the question what you're looking for. So when I graph this function and it looks like this, okay? I just screenshot the app, but obviously you want to make sure you know how to do this on the graphing utility. Picture what's actually happening here. This is a person standing on a diving board. So the person standing on the diving board, this is like they are the y-axis. The same was true for the punter. The punter that was about to kick the ball. The punter, the person is the y-axis. So we don't even worry about what's happening before this because that's not actually existing. The person doesn't like shoot up out of the water, come up, stand on the diving board. That doesn't happen. Just like if I'm going to throw a ball, nothing behind me is important. Does that make sense? I'm throwing it forward. So you're worried about the person who's the y-axis and then everything in front of them, not anything behind them, okay? Because I saw some people like add this on to a horizontal distance. Don't do that. That has nothing to do with what's happening in front of you, which is what the problem is.
Are we gonna get one that's like that doesn't go up and down? That's like because the one on Weber's sign, it was like the yard sign.
Yeah, but you had to find the area, and the area should have gone up and down. Because you had to multiply the two sides together.
Are we gonna have it?
No, it's not an area problem. Yeah. So then it asks these questions, right? So like, what's the max height of the diver? So the diver goes up and comes back down again. I need to know the max height here, which is the K coordinate of my vertex. Or I trace, I find the max, which is I think this one. I find the maximum coordinate point, which was 313. The max height is 13. Has nothing to do with the 3, okay? The max height is 13 feet. The second question says, how high above the water is the diver when they stand on the board? So that's your y-intercept. It's the same kind of concept as the punter was holding the ball, and the question was, how high above the ground is the ball? That's your y-intercept, okay? So that's this vertical distance, the y-intercept, which can be found from your equation, or you literally go y-intercept and you find that coordinate point on your graph, and it's going to be 0, whatever that y is, which in this case was 9. The third question is, what's the horizontal distance from the end of the diving board to the point when the diver hits the water? So we're talking now horizontal distance here, which is the same thing as finding that 0. So your answer is either going to be part of the max, part of the y-intercept, or part of the 0, depending on what it asks. You've just got to be able to decipher what it's looking for.
So you have to find the 0?
So you'd have to find the 0. So on your handheld, your second trace, go to that calc, get to 0, trace it, and then it looks like this. This is 0, right? So this would have been 8.40 is that coordinate point there. So 8.4 is how far it is from the base of the diving board. Again, we don't add this back here. That's not part of the distance from the person or the diving board to where it enters the water. Don't add behind it. It's not like
Horizontal distance is 0.
is the 0. Yeah. You've got to be able to like be comfortable. This should take you like 3 minutes to take this part of your test. You can obviously come back to it at the end like we did last time, but it should not take you long.
For these types of questions, it's always going to be like that, right?
Yeah.
Or, okay, so as long as you know the concepts like that,
Yeah.
that'll be fine.
Yeah. You just got to understand what the words mean in terms of what we're looking for, right? That's sometimes the hardest. That you correct is this. There was a mistake. Okay, this should be number 15. I left it as like minus 9 at the end. So it should have been x to the third minus 7x squared plus 13 minus 3. I'll update what's on the key, but if you already downloaded it, it's wrong. That's number 15.
Plus
X to the third minus 7x squared plus 13x minus 3. Then came 2, which was the 2 things that were on the warm-up that we did today. Finding the end behavior, finding your zeros and your multiplicity, and then your y-intercept, and then drawing your graph. And then the last thing, which is the one that had the mistake on it, okay, when I give you the roots and you work backwards to get the equation. Questions on those? Yeah.
On number 10,
Mhm.
I don't understand why K is...
Hang on, let me move this. There we go. Okay. When I graph it on the handheld, it looks like this because my window's set to 10. I actually lose the top part of it. So you can either zoom out or you can adjust your window until you make sure you get that curve, okay? Now, the purpose of this is to get the graph, but then you have to read what it's looking for. So the first one says, what's the maximum height of the diver? That's the maximum height, which is your K coordinate of your vertex. So if I want to get that, I go second trace, I go max. I'm left of it already, then I have to go right of it. Oh, man. Left, right, and it's going to bring you to that coordinate point, which is that 313. I know the 3 would be like how far from the diving board does it hit its max? That would be a 3 feet. But what is the max is the K, which is 13. Then it says how high above the water is the diver when they stand on the board. If the board is where the y-axis is, right, then you're looking for how high above the x-axis it is, which is your y-intercept. So second trace, value, sorry. I want when x is 0. And there's my y-intercept at 9. You could also get it from your equation, right? Then it says, what's the horizontal distance from the end of the diving board to the point when the diver hits the water? So if the y-axis is the end of the diving board and it hits the water when it literally crosses through, right, because that's your water level, I'm looking for a 0. So second trace, I want the 0. I would go to the right, go past it, hit enter again, and my 0 is 8.40. So that time it didn't even give it to me in scientific notation, give me exact. So you just got to know you're going to kind of get one of those 3 general types of questions. They're not going to be like so out far-fetched that you've never been asked that kind of question before, but it's not going to specifically be the height or specifically be, you got to figure out what that is based on what it's asking, okay? It's always going to be something that's quadratic, so you're always going to get a parabola, and then you just got to figure out, I would say if it's a person, always put that person on the y-axis, because for me that's easier to visualize. And then ignore everything behind it because nothing is actually happening behind it, right? unless they were like laying on the floor and then throwing it up, which I'm not going to do to you. Okay, if they're standing and they're throwing the ball, it's going to make that natural curve coming from the person. It's going to go up and it's going to come back down again. So how high is it if it's in their hand? That's your y-intercept. How high does it go? What's the max height? That's your k. When does it hit the ground? That's your 0. Or when does it hit the water if it's like this? Yeah.
Would you give us something that doesn't go up before it comes down?
No, it has to.
Okay.
Yeah. I mean, there are things that can swing like a pendulum that would swing down.
No, but like.
But the ones that we're gonna do they'll always have a negative ax squared, which makes it have a max.
Okay.
Yep. Because you're going up and coming back down again.